Hello, welcome to It Can Be Coded. Mm, today, today we'll solve a code force problem of rating 1000. So at first we'll set the difficulty as 1000 and then apply. After that we'll sort the list. Then we'll go to the first problem. As you all can see, the name of this problem is read to 0. In this statement you can see that you are given two integers x and y. You can perform two types of operations. Operation number one is pay $8 and increase or decrease any of these integers by 1. For example, if x equal to 0 and y equal to 7, there are four possible outcomes after these operations. X can be 0, y can be 6, and x can be 0, y can be 8. X can be -1, y can be 7, and x equal to 1, y equal to 7. At the second operation, pay $B and increase or decrease both integers by 1. For example, if x equal to 0 and y equal to 7, there are two possible outcomes after this operation. And there's x will be -1 and y will be 6, and x will be 1 and y will be 8. Okay. Your goal is to make both integers, given integers equal to 0, and x and y will be same. I mean x and y equal to 0. There are no other requirements. In particular, it is possible to move from x equal to 1, y equal to 0 to x equal to y equal to 0. Calculate the minimum amount of dollars you need to spend on it. Sorry. So in the input section, we can see the first line will have the number of test cases, like here is the number of test cases, and each of these test case will contain two lines. First line will have x and y, and the second line will contain a and b. To solve this kind of problems, so let's explain this problem in further steps. I hope you all can see my board. So here we have two kind of operations, and operation one is we have to increment both any of the two value or decrement. Suppose we have x and we have y. Sorry for the handwriting, actually I'm using mouse pad, so I'm not quite used to it. Okay. So in the first operation we can increment or decrement the value of x or value of y, and in the second operation it's an OR operation. So in the first operation we can increment or decrement the value of x or value of y. Value of x or value of y, and in the second operation we have to increment or decrement value of x and value of y. So these are our operations. In the first operation we can increment or decrement value of x and y, and in the second operation we have to increment value of x and y both at the same time. So in the problem set you can see that the range of x and y starts from 0 to 10 to the power 9. And we have to make x and y both equal to 0. So we have to decrement the value of x and y. We never have to increment the value of xy. Why? Suppose the minimum value x can have is equal to 0, and the maximum value of x can have is equal to x is equal to 10 to the power 9. Okay, so we can see if we want to make x is equal to 0, then we always have to decrement or we have to do nothing, but we never have to increment the value because our targeted value is 0, and for getting the result 0 we never have to increment the value of x. So we can say we can follow only one task, that we have to decrement the value of x and y. Okay, this is one possible thing. The second possible thing is we can check that if 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 x equal to y equal to 0. So at first we'll check if x equal to y equal to 0. If it is already 0, we don't need to spend any dollar. So the result will be so the result will be 0. At the second step, if sorry, so if x is equal to y, x equal to y, so in the second step we have to check if x is equal to y, and so as we are saying, if x is equal to y and x is greater than 0, so if the two value is same and x is greater than 0, then we have to decrement the both value into 0. So we will increment the both value, but we have to check two operations, because when we will decrement with the operation 1, it will give one amount of dollar, and when we will decrement with the second operation, it will give us the second amount of dollar, and we don't know which operation will give us the minimum amount of dollar. So we will check the both. First we will decrement the x and y into 0 with the operation 1, then we will decrement the x and y into 0 with the operation 2, and then we will take the minimum of this $2. So we can say if x equal to 0 and x greater than if x equal to y and x greater than 0, then we will take $2 is $1 $1 is equal to, we will take from operation 1 so $1 is will be from operation 1, and $2 from operation 2. So this is our two conditions, and we will pass our third condition, which is if x is greater than y. So if x is greater than y, what we'll do, we will set dollar is equal to, so x is greater and y is minimum value. So when we will convert x into y, we need operation y or 1, because operation 1 can perform on a particular number and operation 2 perform on the both number. So how many times we need to perform the operation 1 on the x, because x is greater? So we need to perform this operation x minus y times. And how many dollar it will cost? X minus y into operation 1. Operation 1 cost $1. Like here we can see, pay $1 and increase or decrease any of this integer by 1. So operation 1, pay $A. So to perform operation 1, we have to pay $1. Okay, and this is the amount of dollar we need to pay to convert x equal to y. Okay, after x will become y, we have to perform the operation number 2 to decrease the both value into 0. And how to get that dollar? We have to plus it with y, because y is lower and we are converting x into y, so both are now same, into b. Why b? Because to perform operation 2 we have to pay $B. So after that we have the minimum dollar and we will print it out. This is our result. So let's revise the whole process once again. If x equal to y, we can directly print 0. Why? Because it's already set it to 0. If x equal to y but x greater than 0, so the two numbers is same but they are not 0. At that time we will perform operation 1 to calculate the amount of dollar it needs to convert it into 0. Then we will perform the operation 2 to again it convert it into 0, and we'll check which one is minimum. $1 is minimum or $2 is minimum. The minimum amount dollar will be our answer. And in the second time, if x is greater than 0, $1 will be x minus 1 into a plus y into b. So here we have to remember that it is when x greater than y. When y greater than x, this process will repeat, but this will interchange. So here x will be y will be x, and here y will be x, and other properties will be same. The explanation part is over. Now we will go to our main part, the interesting one, coding part. Okay, So at first we will include all the files. At first we'll include all the header files. Setting up main template. Our template is done. We'll check the test case. After the test case, we'll check the value of x, y, a, b, x, y, a, b. Okay. After that, we'll check if x equal to y. X equal to y, and we have to check two conditions. If x equal to 0, then we can output 0. Okay. Don't forget to print the end line. If x equal not equal to 0, then we will, if x not equal to 0, according to our algorithm, if x not equal to 0, when x greater than 0, we have to check these two things, $1 and $2. So we will calculate this later. At first, we will go to the step 3 to calculate x greater than y, this operation. Okay, if equal to 0, then else if x greater than 0, then we can print out x minus 1 into a plus y into b. Then in the line else y minus x okay. Then now we have to find how with the two operations, I mean operation 1 and operation 2, we can find $2 where x and y is both same. So operation 1 works on any of these integers by 1. So operation work on one integer, and operation 2 works on two integer, I mean both integer. So when when x equal to y, we can perform the operation 1 at a time at a single integer, and when we want to perform the operation 2, we can perform this operation at a time on the two integer. So we can have $2 that will be operation 2 is equal to, so let's calculate something else. So how we will have $1, let's calculate this. Okay, and we will find how to have the $1. Suppose we have x is equal to y equal to 3 and the value of b equal to 2. So when we perform the operation 2, it will perform on both numbers, I mean x and y. So you can see this is 3 will become 2 will become 1, and after that 1 will become 0. Okay, so from 3 to 2 and 2 to 1 and 1 to 0, we need $2, $2 and $2. In total we need $6. So we can say the value of $2 will be x into b. Okay, so let's go to our code again, and dollar will be x into b, and $1 will be, again let's go to our browser and check how can we find the $1. So this is when x and y equal to same. If they are 0, the answer is 0. If they are more than 0, we have $1 and $2. If x greater than y, this is our equation. If it is y, is our equation. $2. So you can see x and y are same. This is our $1 and this is our $1, and we have to find the $2. Okay, so in $2, you can see from this statement that option A can perform on a single element at a time. So we can say the dollar we need for option 1 is equal to x into A plus y into A. Since x and y are same, we can say x into A plus y, x into A. So x into A plus x into A is equal to 2x A. So this is our second equation from which we can have the $2. So this will be our $2. This will be our $1. $2 is equal to the dollars we'll have from the operation 2, and $1 will be the dollar which we'll get from the operation 1. Okay, let's get to code, and dollar is equal to x into this is our $1, and we will character out minimum of $2 into $1. Hopefully it will work out. Let's see. Okay, so from the output we can see these two are our output. The first output is 1337 and second output is 0, and in our code the output is 167 and next one is 0. Okay, let's submit it now and let's see if it gets accepted or a WA. There is something wrong with this code. I'm not sure, but it's saying that wrong answer on code 2. Let's see the code. Actually, now it's feel like I am a programmer. If you don't get WA, you're not a programmer. So I think I found the bug here. It's like it is the bug in this place. So let's reformat it. So what's going in here? After getting this, we are always adding the operation 2 after this, but sometimes it's not necessary to use the operation 2 every time, because operation 2 can cost more dollar than operation 1. So after converting the two number into same, we have to check which operation we'll use, operation 1 or operation 2, like we did it before. Okay, so we will not use the operation 2 here. Here we will also not use the operation 2, and we will not print that answer. We'll take it in $1. Okay, we'll take it in $1. After that, we will use this part. Okay, so we at first we are converting the two number into same level by doing this operation like I explained before. Then we are performing operation 2 to find the dollar for operation 2. Then we are performing operation 1 to find the required dollar for operation 1. Then we'll have minimum of $2 and 1 plus dollar. Okay, let's see if it can work or not. Okay, we're getting the correct answer, 3370. Let's check another custom answer. We have discussed 1, 11, 47, 1. Answer is 464. Okay, looks like it's open. Okay, now it's time for the hard part. Let's submit it again. Oh wait, let's check. End line, end line, end line. Okay, okay. Let's see if it works or not. Another answer. What's going on, man? Wait a second. Another bug. So when x greater than y, we're calculating the dollar to convert x into y. I think I found the bug again. So when x greater than y, we're converting x into y. So $2 will be y into b, and $1 will be 2 into y into a. And else means here a y greater than x. So here y minus x and x into b, this part is okay. So there was problem in this part, and here both part is same, so x and y it doesn't matter. So let's try it out again. Okay, finally accepted. So this was all for today. I hope we'll see another problem next time. Thanks for watching.